Hey, hi. So this channel is going to track my progress in embedded systems. I'm going to learn embedded systems and teach here for myself, and it might help be helpful for you to get into embedded systems. It's gonna be a 30 days series where we are going to learn industrially relevant skills to get into embedded system internships or jobs. So if you are interested in this series, do comment down and let me know. Without any further delay, let's get started with the day one basics. So, for the day one, we are going to learn embedded systems. So, generally, what's embedded system? Embedded system is a combination of hardware and software which works for a specific task under a relevant or particular interval of time with set of rules. So, these embedded systems are going to be a part of a system which is a part of a large system which is going to work on a smaller part. You might be asking, so what's the difference between the embedded system and a normal computer? So when coming, so let's compare what's normal computer versus embedded system. So normal computer can serve multi-purposely, while embedded system only serve for single purpose. It has high memory. So embedded systems has limited memory. Normal computers can be accessed on Mac, Windows, Linux. Generally, embedded systems are only firmware which work only for a shorter duration and a shorter time interval or shorter work. So these are generally customizable, but these are going to be fixed when one embedded system is designed. It gonna be fixed for only particular task. Generally, you might be asking, so that's okay about embedded systems. What's the architecture? So architecture, coming to the architecture, it goes like sensor, microcontrollers and output. Sensors are going to be the input, and microcontroller is going to be the brain of the system, and we are going to get the output. So let's go brief about the input, the sensors. So sensors might be temperature sensor, humidity sensors. The name indicates that the sensor is an object which senses a change in the environment. Is an sensor. There might be multiple sensors which we are using in further journey. So microcontroller is going to act as a brain for an embedded system. Microcontrollers generally have a limited memory. It also stores data. So it's gonna process the data and make decisions as per the outcome we require. So the examples are going to be Arduino ESP32 and STM32 and PIC controllers. And the output devices are generally LED motors or any other output devices which when an input is given we require an output, right? So the devices which exhibit the output are generally output devices like this. So what's the difference between microcontroller and microprocessor? This is very important for interview. This question will be asked in these systems. So here microcontrollers and microprocessors. So microcontrollers is a chip which consists CPU, memory and IO, and microprocessor only has CPU. Used in embedded systems. So this has the memory and IO, but as it has only CPU, we need to add external memory which is generally observed in computers. So these are compact but tightly packed. This does not consume any power or low. These consumes only low power which are used in real-time operations like Arduino and ESP32, while microprocessors can be observed in Intel i5, ARM Cortex. As we are going to learn about industry relevant skills, the types of embedded systems are RTOS, standalone, and network embedded system. RTOS refers to real time operating systems. These are time sensitive. When these fail, it might cause human loss or an economical loss for the person. Generally, a big example could be airbags. Standalone or independent, these systems do not depend on other systems for the output. These are generally going to work on by themselves. We can observe washing machines, they do not need to depend on the outputs of any other devices. And network enabled systems, as the name suggests, network enabled, these need to be connected to other devices, generally IoT devices. We are using microcontrollers as the main brain for the embedded system. So let's get a brief information about microcontrollers. So these are generally represented as MUSI, which is microcontroller. Examples of microcontrollers are electric chimney, microwave, washing machines. It also, when a microcontroller is taken, it also consists a microprocessor. So this microprocessor also consists a little memory. These microprocessors are not the standard microprocessors which will be used in separate systems. These microprocessors are part of microcontrollers. So let's understand it with an block diagram. Generally, this is the block of microcontroller which consists of microprocessors, memory, timers, and interfacing circuits. So these microprocessors are, we can observe in washing machines. So we have basic functionalities like heavy wash, turbo wash, which are going to be functioned and be stored by microprocessor. It also has memory and timers. What is the time required to complete the task, and the interfacing circuits which we can observe in, like, take an example of microwave oven. It has many multiple buttons, so these are connected with these buttons. When we click this, the function which is going to be the processor, the memory integrates with it, the timers also integrate with it, and which makes a microprocessor control efficiently to the device. So you might think, so what and why are we learning this? This is the real workflow of an industry, of an embedded system engineer. They design hardware circuits, they write embedded C firmware programs, interfacing sensors, debug hardware and software, optimize power and performance, test and deploy the product. So what we need to understand about it, hardware and software. So how to read data sheets for multiple circuits or components. We need to debug the components or the software and to build projects. So that's it for this video. So there's a task that how much of the amount of information did you get. So there are two tasks. Task 1 goes like, list down 10 embedded systems around you. So to make it sure, it's gonna be input, processor, and output. Input are the it's about Arduino Uno and ESP32, which are microcontrollers. So let's meet for the day 2.